Brian here from quantlabs.net. In this video, I'm going to talk about a book that's critical for development of a let's say high frequency trading like system. So I'm here in Amazon. The book I'm talking about is C++ Concurrency in Action. It's a fairly, I won't say recent book, but about 2013. And it's an important book for a variety of reasons. If we look at the various options for developing trading systems, as things become more competitive, I guess you could say, it's going to be more and more imperative that you've got a good understanding of your trading platform, and most of all, using proper coding techniques to get it properly running and not blowing up and having less bugs and whatnot. The key behind it all, as where it started, was early last month. I was assuming I'd be able to take on positions, namely in my paired trading, and be able to hold on to long-term positions, month to, let's say, 90 days. As I started analyzing it, I started realizing the same opportunity on the same pair could happen multiple times in a day. So the question came out, why would I want to hold on to positions for long-term when it's more risk to do so? So I started really, once again, focusing on the intraday type of analysis and trading execution, which led me from libraries like OpenHFT, which was in Java, to Intel threading building blocks for multi-threading, and then to this book, which is based around the C++ threading standard library as part of the C++ that came out in version 11. So that's what this book really focuses on, and during that same version of C++ was lambdas, which made coding much easier in C++ as well. So there's a lot of focus on that as well in this book. So it's really essential, I would say, and I've said this before in my more recent videos, where this kind of program will come into play is you run your analysis in whatever language, Python, Java, whatever you choose. You have an idea, you have a position, and let's call it a market opportunity. You put on your position, so now you want to be able to analyze market data among other types of data to measure your exit out of that position. And especially if you're focusing on intraday, you would want to do it in a pretty sophisticated and robust multi-threading environment. So looking at Java, it may do the job, it may, but there's you have the Java, the garbage collector to really worry about, where C++ is really good for, handling your own memory. So it gives you more control. And this book, when I started looking at TBB, I started to realize their book was not very rated well. And I think this was the deal breaker for me. Let me just load it up here. So if I go to the threading building block site.org, at the bottom here, you will notice the only book that they really have is this one, Processor Parallelization. And I started realizing that it's not rated all that well. This other book I've not looked at either. Let's just check it out. This is a fairly new book. But either way, I will say this book I know is not rated well. And the problem is with this TBB is it's an external dependency. It's a good dependency to have. It's very good. Nothing wrong with it. But one of the key items when it comes to high frequency trading like speed, you want to have as few dependencies as possible. So when you start using the standard threading library, that's not an external dependency. That's external, or that's part of the standard C++. So that's one less dependency you need to worry about. And over, I'd say 50% of your operation is going to be done in multi-threading environments. Namely, let me give you an example. Pair trading, which I'm working on right now. Obviously, as I said, you will be probably doing a bunch of analysis in a bunch of separate processes, Java, Python, whatever. And you know you want to put on a position, and then you put on a position. Then the key area, there are two key areas that you got to worry about is your multi-threading strategies and how you implement them. And the other one that you got to worry about is your database. Originally, here in my past videos, you'll see a couple of videos on SQLite. Let me just see here, SQLite. Right here. This was done about a week ago, I guess. And I started realizing SQLite works great if you have one program, whereas I'm going to be having probably 3 or 4 processes communicating with each other. So you need to have a really efficient database. And that's where I've always really liked NoSQL, specifically Redis. So SQLite's good if you want to build out a monolithic kind of application with all your trading in one application. That I think SQLite will be very appropriate for that. But for me, I like to have replication and so forth built in. And again, I've talked about that many times in my Redis playlist, so just go there. So Redis is what I'm planning to do. Bringing me back to here with the concurrency in action, this really opened my eyes on a number of things, because when you look at Linux and low latency and low level processing that you want to weed out so that you can have more focus on your trading system, what you want to do is you want to make sure that those processes are dedicated and there's nothing else competing for cycles on your processors in your whatever box or server you're going to install these things on. So with that in mind, the way I'm planning to architect it may work out pretty nice. So enough of that. Let's talk about the concurrency as well. So with this book, it really opened my eyes on a number of things regarding memory optimization in terms of having off the heap, on the heap, being able to optimize the number of data, what type of data, the size of the data in your data structure, in your threads that you want to have control over. So I'll go into those in detail. So let's talk about the website itself from the publisher, from Manning. So here it is here. We have here obviously the different chapters. Specifically from this resource, there's a couple of things you may want to know about, which is good. We have our source code here that we can download from the book. Boom. We also have a forum, which may be useful for basically sending out requests of help maybe. I still prefer Stack Overflow, which can be very helpful and more immediate as a response. So that's the publisher website, and let's get into the fun stuff. Okay, so we know Amazon's very good for a number of things, but some people may not know this, but you can take a look inside the book. And the cool thing is you do an assessment on the book on table of contents and the book cover. So I'm going to go chapter by chapter here. All right. So the first chapter is value of concurrency. What is concurrency? Concurrency, multi-threading, blah, 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 blah. And then it goes into the basic thread management and identifying threads. Fine. Then it gets a little more hairy, sharing data, protecting data, and this is usually using mutexes and semaphores, which means you're locking data components within your code, which means it's blocking. Now, if you're trying to do something that's a little more sophisticated, meaning it's non-locking or lock-free, there's a chapter that focuses on that, chapter 7, but I'll get in that in a minute. So there's many different examples on how to do this. Now, the key behind this is it really, really comes down to on your trading strategy, on how you plan to implement it. I don't think there's a real model or pattern that you can use for it, because each strategy, trading strategy, will have a different goal. So, for instance, if you are, and this is where your architecture really comes really key to enhancing the speed and optimizing of it, and the complexities, and as well maintaining it. So, for instance, you may want to use, for paired trading and arbitrage, blocking and locking, and I'll explain that in a minute, versus lock-free. So it depends upon how you want to work out your strategy, and I'll try to explain that in a little bit. So here in the synchronizing concurrent operation, what we're dealing with is here. Yeah, I messed that one up. Okay, let me just rescale here. Okay, I'll just accept whatever it comes at. All right, so let me just get this back in gear here. Table contents. Ooh. Okay, so there we go. Okay, so as I said, chapter 2, we deal with launching threads, running threads, waiting for thread to complete. That's pretty important in the world of your trading algorithms. So let's say in my case, we could have 4 types of algorithms running in parallel. So you have a trading pair, you're interested in it. There's multiple ways to exit that position once you enter and put the position on. The first algorithm you may use is simple average true range. Another way to have another algorithm running in parallel will be, let's say if you want to apply stop losses. Another one would be setting a soft target. So all of this stuff has to be done on the fly. And then the other set of algorithms that I'm not giving full thought on are your basically your risk management, or maybe your trading performance. So for instance, if you have a pair trade running, you're trying to measure the exit, you could use average true range as one method to exit the trade. The other algorithm you would use as a stop loss. So I don't know, let's say if you set a stop loss of 2 deviation from your position when you entered it, that's one thing that you have to calculate. And at the same time, you may have your soft target may change due to market conditions, because if the volume of execution of those orders of your set of stocks that you're watching after you put on your position, they may go up or down. So that's radically going to change your soft target on the fly. On top of that, if you've got maybe a system that is just adding on more positions and you want to protect your account, so you will have to watch how those positions do on the fly against your overall portfolio, because you may have one winning trade on the fly, but you may have 5 other positions that may be losing. So using something like Kelly criterion, you can easily calculate how those positions are doing and how the one position that you're watching here is doing, and then be able to close out your position on that. So you have many different metrics that may want to run in parallel when you watch particular assets or positions. So pair trading, you could have virtually, let's say, 4 different types of algorithms in parallel. Plus, remember, you're watching 2 assets, not one. So you're going to be running really 8 assets. So you have to double up on your long and your short when you're taking on those pair trades. Really important to understand that. So you'll be sharing data between each of these threads that are watching your algos, and you're going to be most likely using mutexes or semaphores to lock and protect that data, so that other threads will not come in and inadvertently do a race condition to wipe out that data, right? So also in this chapter here, I think in 3 we cover topics like deadlocks, which is really important when we spin up threads, and again, protecting your data. So you do that through different types of locking mechanisms, like this unique lock that's mentioned, and so on and so forth. So interesting techniques like this recursive locking. As you can tell, my perception is when you start just learning quick and dirty tutorials off of some blog or some lessons in YouTube, you're going to miss out on a lot of opportunities of the overall full capability of something like this library, this C++ standard threading library. So again, we look at the concurrency in chapter 4. We can set conditions on when to get out of threading or to close off the threading. So that's maybe do a join on a bunch of threads, getting the results, and then be able to say, well, we've now calculated our exit, or we met our exit condition. Let's basically exit the trade and basically release that thread so other threads make the thread available so other processes can make use of those threads. Because when you're dealing with a system that only has 4 threads or 12 16 threads, it's all about optimizing those threads. All right, so we're also going to be dealing with futures. So here, what that really is that we know we're going to hit a result of some kind. So in our case, let's say an exit on a position. So we can set that as a future. And then once we hit those conditions, we can basically close off those threads, those algos, and basically exit. So we can also use these promises as well. And of course, sometimes you may want to use time limits, but well, that's possible if you want all your positions to be closed off by, I don't know, end of day trading for New York, or end of day trading for a particular exchange. So you're not going into that overnight risk. So here, the funny thing is, when I've looked at external libraries that do the same thing as this, Kafka is one example that is just brutal and just bloated libraries. Like these libraries, the code demos that I've seen, maybe a couple of 100 lines, but when you compare it using an API or a framework or a library like, let's say, Kafka or RabbitMQ, it just adds a complexity and just makes the processing even more complicated, more slow, more things to maintain. Here, doing it in C++ is much, much easier. I won't say simpler, but when you get through it, it's much easier. One thing I need to say, if you're new at all this, you better be a fairly accomplished C++ developer to really understand this. This book is not going to teach you C++. Okay? You're going to assume that you have a fairly decent knowledge of C++. And the other cool thing about it is using templates. So it's not really consuming, well, it is consuming state, but it's just easier to maintain because all the template functions that are used are generic. So you can pass in all kinds of different structures, classes, or whatever into these functions. Also, memory model, operation, and atomic types. Now, this is really important to understand because we're moving out of serial type of processing, moving into multi-threaded. So obviously your data types change from, let's say, int, float, double to atomic types. So when you're using atomic, that means that they can be shared in a multi-threaded environment and protected. So this book does cover a lot of those and how to properly use them. Funny thing is that there's some pointers that are also used. So you can basically move data by just moving a pointer instead of like a physical copy of memory, which will greatly enhance the speed of your processing in a multi-threaded environment. So this chapter really covers that, which is really powerful to understand, which was kind of new to me. This chapter here, or this section, synchronizing operation, enforcing ordering, this can be useful if you are running various let's say algorithms with your trading and you're dependent upon one algo to finish up before another algo. So you would want to look into how to enforce the ordering of those results. Okay, so now we move into the next two big chapters here. So this one is how to have your shared data. Oh, before I forget, this memory model is really critical as well because it covers how to optimally set your data structure, the size of your data structure that you're using in your multi-threaded environment to ensure it's fairly small, because it covers quite extensively when you have too many threads running in your C++ application, but there's only so many available threads on your processors. It actually, what you're trying to accomplish will basically make your system or C++ multi-thread actually run slower. So this will cover to ensure that you understand your memory size of your data structures that you use to optimally run them to properly get best performance, basically. So then chapter 6 here, we move into block-based concurrent data structures. Here we go into thread-safe queuing. Now queuing is really important because it's what we're dealing with. Is if we're running data on a queue, meaning let's say we have rolling windows that you may have heard me talk about in previous videos of, let's say, 100, 1,000 market data points for a particular market asset. That's going to be run on a queue. So you want to make sure you're running that properly, optimally, and have your algorithms process those queues in an optimal way. So again, it covers all the different scenarios. Here we do a find or a lookup as well. So shows you coding examples in that. Now this is the really good one that will be for chapter 7 for HFT level type of systems, because it's lock free. Okay, so what they're doing is the key ingredients is using pointers. As I mentioned before, you're just copying data from one type to another. You're also using data structures that fit within your registers as well. You need to make sure it's thread safe. A lot of other conditions that you need to worry about are they exception free, so that they can run without needing to raise exceptions. It's covered in here as well. Something I never knew about, hazard pointers, very useful. Managing your memory and lock free data structures, again, really important to understand that. Applying it in a lock free stack, and again, writing free lock thread safe queues. really, really important because queuing is really what you're building all your data on. Lock-free memory reclamation scheme. This is pretty good for if you need to reclaim all of your data that you need for another instance. The ABA problem, again, it's similar to the race conditions that you could have where you have one thread or one data result moving inadvertently ahead of one other thread, and then have another thread get in, like the same thread be impacted by that data. How to handle the busy wait looping and all that. This is really eye-opening. But again, this is kind of critical if you want to write really pretty fast multi-threaded applications. And this is where your strategies, when you put on a position and get out really fast, this chapter will really open your eyes on that, how to really write proper lock-free concurrent data structures, I guess. Another one that's really important in chapter 8 is concurrent code, designing it. Just trying to remember here. Oh, right. So depending upon how you want to write your strategy, you may want to basically split up your data into concurrent threads. So again, I'm not sure if this can be really useful for like live trading strategies, but it could be useful for things like Monte Carlo simulations and that sort of thing. Factors affecting the concurrent code. Remember I was talking about how the data, the size of the data, and how it can impact. These examples here cover that over subscription, excessive task switching because of your data structures may be too big, fault sharing, ping pong conditions. This was really good. Designing data structures for performance, again, covering all the different, making sure that your data fits properly within your registers and whatnot, or sitting on your processors. Additional considerations, scalability, hiding latency with multiple threading. So again, this is going to be really important, a bit depending upon your algorithm. So if you have one algorithm that takes too long, one thread that is got a worker or a node where the algorithm takes too long to calculate, this is where you're going to get hit on these latency processes or threading, which is not good. So this will cover all that. You can see how critical things are when you look at these in a multi. It's not so simple. So you have to figure out all the different scenarios that you would run into on your particular strategy, especially if you're trying to move into a high-speed environment. Again, concurrent code and practice, parallel implementation of standard for each, how to parallelize like for loops, again, find examples, partially summing. This again would be useful for, let's say, Monte Carlo. This was really important. Now, I'm trying to determine, okay, we're moving into chapter 9 versus chapter 7. So chapter 7 again is lock-free, but here when you're running threading pools, how to set up threading pools to optimize your available threads and then prioritize your threading based around what's available. Contention is a big deal, and there's work stealing, which I never knew about as well. So this is really critical, but again, this technique is using blocking and locks. So question would be, wouldn't it be nice if we could run thread pools in a lock-free environment? That I'd like to know. Interrupting threads, how one thread could interrupt another thread, how you could have a condition that may say, well, let's stop this thread because we've met a condition. So that will free up that thread. So you don't, let's say for instance, you wanted to do an analysis on a particular set of data. The data through the through the analysis says prematurely, we're done. We don't need to run the full process. So terminate the thread to make it available to the next available thread. We can prioritize our blocking calls, so we can set up loops, so we can basically terminate those blocking threads. So again, really impressive on things I never knew about in this book. Testing, location, concurrency related bugs. Again, a lot of it deals with asserts. And then the really nice thing I like about this book is because, as I said, it's for post C++ 11. So there's a good section on those features that are used throughout the book. So if you're new to it, I would strongly recommend you read this section first to really understand the coding techniques used throughout the book. This one's quite interesting, the comparison of concurrency libraries. There is pthreads, the standard threading library that this book focuses on, and as well as Java. The funny thing is that Java does have the threading capabilities of what the standard C++ standard threading library has. But the funny thing is, being a Java guy, I personally wouldn't do it. It's just because you're competing against the garbage collection, and if you're writing crappy Java, you're going to be consistently competing against the garbage collection. And the funny thing is that when you look at the Open HFT library, they talk a lot about trying to minimize the garbage collection. So from my point of view, you're still collecting crap, and you know that is eventually going to slow down or eventually complicate your execution of your application Java. So I can see why a lot of firms, HFT firms, don't really want to use Java in these kind of environments because they always have to compete against Java, and I can see why C++ is used. But the nice thing is here, throughout the book, it shows you all the different examples on how to get rid of the data once you close out your thread. So that's pretty good. In this appendix C, we covers a full-blown ATM example with the messaging and that. It's fairly complicated, but uses all the different coding techniques here. So that's pretty well the entire book, okay, in detail. And this is why I think it's really critical going through this exercise, and I'm kind of glad I've gone through this, that it just really shows all the different conditions that you will need to consider writing a HFT type of system with all the complicated threading that goes on that you'll face. And this book does a really good example of that. And hopefully what I put out will highlight the importance of using, let's say, the standard threading library versus a library like TBB. So yeah, this is a really critical book that I took away a lot of knowledge from, and this author has really made the difference for me. So if you're really new, or sorry, not looked at C++ and really missed out, this is a great book to get really acquainted with, to understand how to really optimize those threads with version 11. And then there's also, funny enough, other videos available on YouTube from this author for let's say threading in version 14 of concurrency. So here's a video of that from this guy Anthony Williams, is it? Yeah. So really important to really get a better handle on all this and use this as your baseline for your multi-threading. I would prefer to do it in C++. Anything else, just not going to cut it with the complexities that a lot of these extra libraries bring. And they may be better, but from what I've seen, I don't think so. Because these are really lightweight libraries and it's built into the C++ compiler. So it removes all those extra dependencies that you don't need, which is key again. That's why a lot of the HFT shops use this stuff. About stats that I've heard, 75% are using C++ and C++ only. They may build their own, but they may use the concurrency or version 11 standard library for all this. And if you did a comparison of the p-threading, the p-threads, this is probably the better way to go. In actual fact, I think some of this is actually built on top of p-threads, so I'm not sure on that. But again, it's just part of the C++ standard, so it's good. So hopefully this will help you out, give you a better idea of what you need to know. And hopefully, as I said, over and out. Talk to you later.